Systems of Inequalities Review. Use the graphs below to answer the following questions about systems of equations and inequalities. We have two equations graphed here. One of them is an absolute value and the other one is a parabola. And for part one, it says, what is the equation of the absolute value function above? I've outlined the absolute value equation in blue. And remembering back when we talked about transforming parent functions, we see that the vertex of this absolute value is at +2, +6. That is going to help us write our equation. This absolute value graph is opening downwards, so we know it's negative. And then we'll talk about A in a second, but this is going to be the absolute value of x minus 2 because our h here is a +2. And then +6 since our k is +6. We need to find our a. With an absolute value, all you really need to do is you need to find what the slope is. I'm going to find a point, and from this point here at 0, 3 to this point here at 2, 6, you go up 1, 2, 3, and to the right 2. So that tells me my rise is 3, my run is 2. So therefore, this absolute value graph has a value of 3/2. Another way that we could find it is we could actually substitute any point that is on our line having an a value here and solve for it. For example, if I use this point 0, 3, I could say that 3 is equal to a times the absolute value of 0 minus 2 plus 6. And I would subtract 6 from both sides to get -3 is equal to a times the absolute value of 0 minus 2 gives us +2. And then I would divide by 2. So we see here that a is -3/2. We have to do the exact same thing for number 2 for b. It says to write the equation of the quadratic. Not sure what our a is yet, but this has a vertex here at 0, -1. So I know that this is going to be x squared minus 1. And I need to find my a. So I'm going to substitute into ax squared minus 1, any point, except for the vertex. So I'm going to substitute in this point to 0. 0 is equal to a times 2 squared minus 1. 0 is equal to 4a minus 1, and I add 1 to both sides, giving me 1 is equal to 4a, and then divide by 4. We find out that our a is 1/4. Part 3 says to use the graph above to solve the following equations, inequalities, and systems. So the first thing they want us to solve is the equation a is equal to b. Well, what is our equation a is equal to b? Our equation a equals b would be -3/2 times the absolute value of x minus 2 plus 6 is equal to 1/4 times x squared minus 1. Now, we are not able to solve this algebraically. There is no way to undo an absolute value. Therefore, we're going to have to use the graph to give us our solutions. We know that the two equations are equal where the two graphs intersect. However, if you notice in this equation, we only have x's. So therefore, all we need is the x component of those points. So we're going to say x is equal to -2 and x is equal to positive 4. For part B, it tells us the system of equations. Y is equal to A and Y is equal to B. This time we have both an A and, or excuse me, not an A and B, an X and a Y. So since we have both an X and a Y, we are going to need to have an X and a Y in our solution. So our solution is going to be an ordered pair. And so looking at the graph, the places where they intersect is at the point -2, 0, and at 4, 3. The difference between part A and part B, in part A, we don't have any Y value. It's just an equation. But we are using has both an X and Y, and we're setting the two equations equal to each other. We're using the equation graphed because that is the only way that we are able to find that intersection. And then for B, we have a system, and the solution to a system is always going to be points or ordered pairs. Part C, we want to find the inequality A is greater than B. Or in other words, we want to find where -3/2 absolute value of x minus 2 plus 6 is greater than y is equal to, not y, is greater than 1/4 x squared minus 1. Or where is for what x values is the absolute value graph above the parabola? So where is that absolute value graph above the parabola? As we're looking up, the absolute value graph crosses above the parabola here, and it goes back below it over here. So we're talking about all of the x values from -2 to +4. Our inequality is going to be -2 is less than x, which is less than +4. And on our number line, we would have an open circle at -2 and an open circle at +4 and a line in between connecting them. Part D is the inequality A is less than or equal to B. So now this time we want our absolute value graph to be below our parabola. Well, that happens on the left-hand side here, and then also on the right-hand side. So from infinity all the way up to -2, and then from 4 all the way out to infinity is where that graph is beneath the parabola. So as inequality notation, we would say -infinity is less than x. Remember, you always have a less than sign when you're dealing with infinity. And that's going to be less than or equal to -2. And 4 is less than or equal to x, which is less than +infinity. On our number line, we would have a closed circle at -2, and the line goes to the left. And then at 4, we would have a closed circle, and our line would go to the right. part E, we're going to look at the system of inequalities. Y is less than A and Y is greater than B. When we're looking at a system of inequalities, we're talking about ordered pairs. And there's an infinite number of ordered pairs that will make these two inequalities true. Therefore, we're going to have to shade an area in our graph. For the first equation, we see y is less than a. So we're talking about y being less than negative 3/2 times the absolute value of x minus 2 plus 6. So we're underneath the absolute value equation. So therefore, we're going to end up shading underneath. Now, if that is slightly confusing to you, another thing you can do is you can test any random point. For example, if we were to substitute 0, 0 into this equation, if it's true, then we know that that's where we need to shade. So I'm going to show that also. So 0 is less than negative 3/2 times the absolute value of 0 minus 2 plus 6. And we end up with 0 is less than negative 3/2 times 2 plus 6. So is 0 less than negative 3 plus 6? It is in fact less than positive 3. So we shade where 0, 0 is located, or on that side of our graph. So we would end up shading everything that is inside of that absolute value. Then we would want to look at the other equation. The other equation is y is greater than 1/4 x squared minus 1. So here we're looking for things that are above it. So we would be shading this region. Again, you could check a point. For example, we could check 0, 0. You never want to check a point that is on the actual line. So 0 is greater than 1/4 times 0 squared is 0. So is 0 greater than negative 1? That is true. So we shade on the 0, 0 side. So 0, 0 is above our parabola, so we would shade here. And then since this is a system, we're going to look for the region of overlap. And the region of overlap is going to give us our solution. For this system of inequalities, our solution is this area here in between the two graphs. For part F, again, it's a system of inequalities. This time we have y being greater than or equal to negative 3/2 times the absolute value of x minus 2 plus 6. And y is less than or equal to 1/4 x squared minus 1. We want points that are bigger than our absolute value or above our absolute value. So this time that's going to be everything that is outside. We could still test a point, such as 0, 0. So if I test 0, 0, I say is 0 greater than or equal to negative 3/2 times the absolute value of 0 minus 2 plus 6. And so is 0 greater than negative 3/2 times 2 plus 6? Or is 0 greater than or equal to negative 3 plus 6? And the answer is no, because 0 is not greater than positive 3. We're going to shade on the opposite side. We're going to shade not where 0, 0 is located. So we're going to shade all of this area here. Then we want to do the same thing for this one, less than or equal to. If we're less than or equal to our parabola, that means we're underneath our parabola. So we're shading all of this area. You could have also substituted a point, test something like 0, 0. I like testing 0, 0 because zeros are really easy to work with. And we want to know, is 0 less than or equal to 0 minus 1? Is 0 less than or equal to negative 1? No, that is false. So that's why we don't shade the side of the parabola where 0, 0 is located. We shade the other side. And then we're going to look for our overlap. The two places where we have the overlap is out here and out here. Also, as a quick note, these graphs were already graphed for us, but if you were graphing them by hand, these graphs, because it's less than and greater than, they should each be dashed lines. So the graphs here for this one should be dashed lines. And for this one, the lines are going to be solid because it's greater than or equal to.